path. All right. Okay, theorem 15. Still not quite dry. Okay. You're given two elements, A and B, belong to your group. Still not dry. Maybe I should buy a hairdryer. Maybe that would help. Maybe just get rid of the whiteboard entirely and use a blackboard. Do everything in a dry fashion. Okay, so you're given two elements, A and B belong to G, and you're told, is it dry? I'll go down. So you're told, oh God, that AB equals E, right? AB equals E. So what can you conclude? Well, you can conclude that that A is the inverse of B, and you can also show that B is the inverse of A. Okay? So that's part one. That's part one of theorem 15 in the textbook. All right. So how do you actually prove that? So what is A? We're trying to find what A is. Okay. I multiply both sides on the right by B inverse. So you'll get A, B inverse is equal to E, B inverse. Okay? Now B inverse, by definition, is just E, right? It's the unit. Okay? And if you multiply... I'm speaking in the multiplicative format terms. When I say multiply, what I really mean is I'm applying the binary operation of E and this. But just shorthand, it's easy. Just say times. So E times B to the minus 1 is just B to the minus 1, right? Because that's the unit. The unit times something is just the something, right? Now A, same comment, so that's just A. So therefore A equals B inverse, right? So we've proved that. So that's done. Now let's try to find what B is. Okay. Now we're trying to isolate B. What's B? Okay. So pre-multiply, binary operation, by A inverse on both sides here. So you'll get A inverse A B equals A inverse E. Right? Now A inverse A, that's just E. B equals, and this is just A inverse. Right? Because that's the unit. Now, the unit B, that's just B. Therefore B is A inverse. Alright? Which is what we've got here. So that's been done. Alright. Part 2. Is it dry yet? Good. So AB inverse, we have to prove that the inverse of AB, see if it's a binary operation AB, so there'll be, the result will be some member of the group. So you're taking the inverse of whatever that is. Okay. Now I have to prove that this is equal to the, right? How do you prove that? So let's say we start here. Let's say let x equal AB inverse, right? So we don't know what that is, but let be x. We're trying to prove that x is this. Okay. Okay. So multiply both sides by on the right by AB. So you'll get x AB equals AB inverse AB. Right. Now whatever this is, you've got the inverse of it, so that'll just be E. Okay? So you've got XAB. Well, now you can probably see where I'm going with this. Okay, so now multiply, in other words, binary operate, on the right hand side by B inverse. So you'll get XAB B inverse equals E B inverse. So you get XA, now this is just E, right? Equals B inverse. So this is just XA equals B inverse. Now, again, multiply on the right by A inverse on both sides. So you get XA, A inverse equals B inverse, A inverse. Okay. Now this is just E, so it's XE equals B inverse, A inverse. So this is just X. So X equals B inverse, A inverse. And that's the same as this. Therefore, this equals this. Right? So we proved it. So this equals that. And there it is. This is that. So that's part two. Now you can probably, there are alternative ways of doing it. Maybe more elegant ways using other theorems, sort of save yourself a bit of work. Remember, when you're making a mathematical proof, you can always import the results of other theorems. And what's a theorem? A bit of revision. A theorem is a statement, some mathematical statement, and its proof. Right? So you can have a theorem statement, such and such is true, and then the proof that it actually is. Okay? So that whole thing, the statement and the proof, is called a theorem. So you can import, you can bring in theorems from outside within your larger proof, your larger theorem. You're trying to create a theorem, and usually what you bring in is usually called a lemma, which is sort of a sub-proof, like a part of the proof. All right. Okay. Prove that the inverse of something is just the something. Okay. How would you do that? Well, again, there's probably various ways. One way is sort of like this. So let A inverse be X. Okay. So if I multiply both, is this going to help? In the textbook they do it this way, so follow the textbook. So start with this. You know that that's true, and we know now. So call that B. Right? Let that be your B. So if AB is E, you proved that B is the inverse. Okay. So let this. Call that B, right? So AB is E, here it is here, this is part one, AB is E. Now from that we proved that B is the inverse of A. Okay? So let B be this, and AB is E. So therefore A is the inverse of B, right? There it is there. Okay? But what is B? Well, B is the inverse. So, okay? So the inverse of the inverse is just the original. Okay. And the last part is you're given three elements belonging to the group, A, X, and Y. They all belong to the group. And you're told that AX equals AY, and you have to prove that X equals Y. Right? Well, not too hard. Multiply on the left side by the A inverse. So you'll get A inverse AX is A inverse AY. And that's the same as EX. That's the same as EY. Now E anything is just anything, so this is just X is Y. Right, there it is. You prove it. So that was pretty easy. All right. I need to clean the board again. Just a moment.